So we want to look a little bit more closely at area under a curve, okay? Now, remember, the definite integral of f of x from a to b gives the area bounded by the curve of f of x, the x-axis, and the lines x equals a and x equals b. And I would throw in here one key word, the net area, okay? Because if part of that goes under the x-axis, we have negative area. So that's going to take away from some of the positive area. All right, so we have a net area bounded by the curve of f of x, the x-axis, and the lines x equals a and x equals b. So this is actually a common way you'll see questions posed in this. They'll say, find the area of the region enclosed by x squared plus 1, the x-axis, x plus 1, or x equals 1, and x equals 2. All right, so here's our line x equals 2. Here's our line, or I'm sorry, that was x equals 1. Here's our line x equals 2. Here is the x-axis. And of course, we've drawn the function already, x squared plus 1. All right, so if you look at these, we have this shape right here. Okay? So this is the area that we're looking for. And of course, one of the things that they're trying to get you to see in this case is that when they ask you to find this area, what you are really doing is you are taking the integral from 1 to 2 of x squared plus 1 dx. Okay? So we're finding the area enclosed here. Now, because they said area enclosed, this is where you really do need to see what that function is. Because if for some reason part of this would have been above the x-axis and part would be below, we talked about how to handle that if we want the area enclosed. Okay? So this problem is actually not asking for net area, but the net area is the same thing as the area enclosed in this case. Right? Does that make sense? Mm-hmm. Okay. And that's because none of it went below the x-axis. So here we have our integral. You guys know how to do this. X cubed over 3 plus x. We use our fundamental theorem of calculus. We're evaluating this from 1 to 2. Okay. Okay. So that would be 3 1/3.
Oh my goodness, I got it right.
Okay? Well, don't act so surprised.
But, Mr. Does that say 8/3 plus 2 minus, and then what does it say in the parentheses?
Minus 1/3 plus 1. I evaluated at 2. So 2 cubed is 8 over 3 plus 2. Then I evaluated at 1. 1 cubed is 1. So 1/3 plus 1. 3 1/3. Okay. Now, another way you might see this is something like this. Find the area enclosed by one arch of the curve y equals sine of 2x and the x-axis. All right, so here we need to apply a little bit of trig because I put the integral from question mark to question mark. When they tell you one arch, you've got to apply your knowledge of trig in order to figure out what the boundaries are that they're talking about. So let's first of all sketch sine of 2x. And you might say, oh, that's easy, it looks like this. Well, yeah, but what are the x values? That's the tricky part here, okay? Okay, you should know that sine starts at 0 at this point, okay? But that sine of 2x, What does that do to the graph of sine? The 2 in there. Not amplitude. Amplitude would be in front of the sine. What were you saying? The wavelength or period, right? What does that do to our period?
Cut in half.
Yes, it's cut in half. Remember, horizontal transformations are always the opposite of what they look like. Okay? Horizontal stretching and shrinking, the bigger the number, the skinnier it is. Okay? The smaller the number, the wider it is.
Vertically stretching or shrinking, it's when the value's outside of or in front of the entire function?
Yes, if this were 2 sine of x, the period would stay the same, but it would go up to 2 and down to -2
Alright.
instead of 1 and -1. Alright, so here it's going up to 1, down to -1, but this, we just said, cuts the period in half. Now, what's the normal period for sine? 2 pi. So the period here is, okay? Alright, so that means this ends here at pi. So if I want one arch of sine, what am I going to integrate from and to?
1/2 to 0, from 0 to 1/2 pi.
There we go. From 0 to half a pi.
Why would it be? Oh, because you're finding half.
They want one arch.
Okay, yeah.
Okay, not one period, because hey, what would the integral of one full period be?
0.
0, because there's an equal amount above as there is below. That would be net area. If we wanted total area enclosed, we would,
2
It-
of what?
we could just double this, right? Yeah. Or we could do this plus the absolute value of the integral from pi over 2 to pi. Alright? But that would be more complicated, more work. So we'd rather just double this. Okay? But this one only asks for one arch, so we're actually only looking for this area right here. So let's see here. We have sine of 2x. So this is one of those function of a linear function. So when I take the integral of sine, what do I need to do?
Negative cosine.
It's negative cosine of 2x, but the 2x means I need to do what?
1 over 8.
1 over 2.
Oh, so 1/2.
Yeah, I need to multiply by a 1/2. So we've got the negative there, and it's going to be negative 1/2 cosine of 2x.
Wait, again, why is it negative 1/2? Sorry.
The negative is because the integral of sine is negative cosine.
Why 1/2?
The 1/2 is because we've got the 2x inside. Okay? Again, if it helps you to do the whole u substitution thing, do it. U would be 2x, so du would be 2dx, which means I need to multiply by a 1/2 on the outside. Okay? So if it helps you to do the du, if you keep messing up that linear thing, that's fine. Just do the u substitution. Okay? So now we need to integrate that from 0 to pi over 2. So, negative 1/2 cosine of 2 times 0 is 0. Okay? Minus a negative 1/2 cosine of 2 times pi over 2.
Wouldn't it be the opposite? Wouldn't it be pi
Oh, wait,
over 2
yeah.
minus 0?
Thanks. I got them backwards. Thanks. Thank you. Yeah, we would have gotten the opposite of our answer. Alright, so that one is going to be 2 times pi over 2, so just pi. And this is going to be the cosine of 0. Alright? What's the cosine of pi?
Negative 1.
Great memory. Negative 1/2 times a negative 1 plus 1/2 times, what's the cosine of 0?
1.
1. So we get a half plus a half, and that's 1. Okay?
Very unsatisfying. When you do all that
So
work to get
basically,
like 1.
the area underneath the curve is 1.
That's what I just
The area underneath this arc here,
But you could totally,
is 1.
you could tell that, you could decipher that from a graph, basically.
Why? How?
Because you know that at pi, if the value will be 0,
It's graded.
because the areas negate each
Well,
other.
just don't do the graph that once.
Yeah, but it could be 2 and -2, or 7 and -7, or,
Solve the integral,
yes.
and then it's from 0 to pi.